4 minutes. That's how long your brain survives without oxygen before cells start dying permanently. You've probably held your breath in a pool and felt that panic kick in around 60 seconds. Your body treats that like a 5-alarm emergency. Now meet an animal that dives 600 meters underwater and stays there for 80 minutes with no oxygen tank by turning its own lungs off. Here's your respiratory system. It looks impressive. It kind of isn't. Right now, your lungs are doing one job: pulling oxygen out of air and dumping it into your bloodstream. You have about 5 liters of blood. Your body has maybe a 2-minute oxygen reserve. Hemoglobin in the blood, myoglobin in the muscles. After that reserve runs out, your neurons start executing a shutdown sequence. First, tunnel vision, then loss of motor control, then unconsciousness. The average person blacks out somewhere between 2 and 4 minutes. Elite free divers train for years to push past 5. Meanwhile, a Weddell seal is laughing at us from under the Antarctic ice. The Weddell seal, Leptonycotes weddelli, lives in Antarctica, dives to 600 meters, stays under for 80 minutes. How? It doesn't just hold its breath better. It fundamentally restructures its biology mid-dive. Step 1. Spleen contraction. Before diving, the seal's spleen contracts and dumps an extra surge of oxygen-rich red blood cells into circulation. It essentially gives itself a blood transfusion from itself. Step 2. Lung collapse. At around 25 to 50 meters depth, the pressure becomes so intense that the seal's lungs physically collapse. For a human, that's called pulmonary barotrauma. It's fatal. For the Weddell seal, it's two-step. Its ribcage is designed to flex and compress without damage. The seal's heart rate drops from around 100 beats per minute to as low as 4. Blood vessels to the muscles, the gut, the kidneys, they constrict. Almost no blood flow. The seal reroutes nearly all remaining oxygenated blood to just 2 destinations, the brain and the heart. Everything else gets put in low-power mode. Its muscles run on stored myoglobin, so dense the muscle tissue is nearly black. Let's put them side by side. At 30 seconds, the human's brain is already sending distress signals. The seal's heart is slowing down, it's relaxing. At 2 minutes, the human is approaching blackout threshold. The seal is still descending. At 4 minutes, the human is brain damaged or dead without intervention. The seal is at 200 meters, just warming up. Your body panics after 60 seconds. Evolution gave the Weddell seal a self-transfusion mechanism, collapsible lungs, and a 4-beat per minute heart. And it still has to come up for air eventually.